Here we have an energy question. We're being asked to find the maximum height reached by an arrow if it is launched upwards, so directly upwards, with an initial speed of 100 meters per second. So previously, we would have used kinematics to solve this question. Now we're going to use energy, particularly the concept of conservation of energy. Whatever energy you started with, you have to have that amount of energy left at the end. So we can think of that as E total initial is equal to E total final. And if this is being launched, presumably from the ground, with an initial velocity of 100 meters per second, is going to move up and eventually come to a stop where its final velocity will be 0 meters per second in that instant where it stops before it starts to fall back down. And this will correspond to the change in height, which will be the maximum height from h equals 0 to whatever the max height ends up being. So if we look at the types of energy we have at the start, we're starting from height 0. So we have no gravitational potential energy. We only have kinetic energy. So EK1, or initial, that's all we have, is equal to, well, what types of energy do we have at the end? The speed is 0, so there's no kinetic, but you're now elevated to a height delta H, so you have gravitational potential energy. So you have EG final. Now we know the formula for kinetic energy, 1/2 m, in this case v initial, squared. And the formula for change in gravitational potential energy is mg delta H. You can see here we don't even need to know what the mass is because those cancel out. They're on both sides. So we now have v initial squared times 1/2 is equal to g times delta H. So if we put those numbers in, we have 1/2 100 squared is equal to g times delta H. If we divide both sides by g, these ones will cancel out. We'll be left with delta H equals 1/2 times 100 squared, all divided by g. And g, of course, equals 9.8. And if you crunch those numbers, you will get 510 meters, which is the max height reached by the arrow if it's launched upwards at 100 meters per second.